Okay, so here we were. So we have the total momentum equals m total times v. And of course, the total momentum is 150,000 kilometers per hour. That's equal to the total mass of both vehicles together times the final speed. And the total mass is 3,900 kilograms. And we have the final speed v, which is now the only variable in this equation. V is 39 times 3,900 is equal to 150,000. So let's figure that out. V is equal to, we can rearrange, 150,000 kilometers per hour divided by 3,900 kilograms. And we can use our calculator to find that. So let's come back over here. 150,123 divided by 3,900. And that is 38.5 kilometers per hour. As the speed for the Hummer Peugeot conglomerate, clump of metal traveling together. Nobody gets hurt in this collision, just to make sure everybody's aware of that. This is a fake collision that we're imagining. Now, that's actually should be astounding for you guys that we are able to figure this out, because remember that the process itself that we started looking at the beginning is incredibly complicated. And we figured that the force diagram, as we mentioned on these, is incredibly complex. And not only that, that's one force, that's the other force. And we casually drew that up here, but we didn't know the maximum value. We didn't really know the specific shape. We didn't know the time that passed. But we just knew that some time passed, that some maximum force occurred, that it had some shape, and that the other object had the exact opposite because of Newton's third law. And we were able to abuse that concept in order to find that the total force is zero. And if the total force is zero, then momentum is conserved, and we can find how fast these two are moving together after the collision without knowing specifically how during the collision the force varies, or even what exactly the value of the force is. That's incredibly powerful, and that's why momentum is such an important concept for us to be able to find things out about collisions mostly, but also some other situations where this can be very, very helpful. And now I'm just kind of nerd sniping myself. Basically, it's only collisions, because we'll call situations collisions that you guys don't think are collisions. So yes, collisions is what we're studying in when we're looking at momentum. How do the speeds change of the two objects? And let's specifically look at that in this case, because this is always a little bit confounding, this idea that the force is equal and opposite on the two objects. And you all know that this situation is going to be much worse for the Peugeot than for the Hummer. So Alex, we mentioned earlier, was eating a sandwich, having an extra big gulp, and doing the American thing. And he probably didn't even really notice, right? Because he went from 50 kilometers per hour to 40, basically, which is like he slowed down a little bit. But he did slow down, but it wasn't a huge change. On the other hand, Octave, the law-abiding French citizen over here, at 0, jumping to 40, basically like this, that is a lot of acceleration really quickly. So it's about 4 times as much change for him as it is for Alex. So even though the force on each is the same, of course, because the Hummer has such a big mass, its relative impact of the force on it is much lower, because acceleration is decided by force and mass, not just by force. And AP Physics 1 loves asking that question, so you have to be ready to answer that. But momentum is conserved, but the impact on each of them is different. Okay, good. So what I'm going to do now is I'm going to turn the camera off, and then you guys can come back on, and then you can ask questions about this, but this is the stuff I'm going to post. So I'm going to, wow, I'm really good at this. Here we go. Where is the button? Aufzeichnung läuft. Aufhören. Aufzeichnung abbrechen. I don't like abbrechen, but I think that's the right button. Let's see. I think